Abstraction is a way that we can repeat what we're doing multiple times in a different way than the way we did with loops. And I think the best way to demonstrate this is let's create a folder called functions demo, and then we'll create some programs in here to demonstrate these concepts. So let's review kind of what we're doing with loops, and we're going to use an example from the book called that shows how to make the Fibonacci sequence. And the Fibonacci sequence is basically these numbers. And you start off with 0 and 1, and then each subsequent number is the sum of the previous two. So 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5. So each one of these is equal to the previous two. So we'll just write it this way for now. And then, 5 plus 3 would be 8. So if you keep going on here, you would get all the Fibonacci numbers. And we could just write that out, but with programming, we can replicate that logic by doing this. We can start off, just starting off with the logic. It's the algorithm is this: start with 0, 1. For as many numbers as you want, append the sum of the two previous numbers So we can do this with a for loop. We can say for I in, and let's say we want 8, range 8. We're going to say fibs.append. And I think I'm going to break this up a little bit just to make it clear. New number is equal to and basically want the second from the end plus the first from the end. So we can do it this way: -2 plus fibs minus 1. And what is fibs minus 2? Well, going from the end, the 1 is minus 1, the 0 is minus 2. So that will initially be the 0. And then fibs minus 1 is just that. So this will take the 2 from the end and add them together. And then we're going to append that new number. It's actually, I'm going to make it singular because it's just a number. So we're going to add the 2 at the end and add it in. And then let's print fibs just to see what we have. So let's put a display results here. And so that's our algorithm for this, to start with 0, 1 for as many numbers as you want and display the results. So let's run that. And yes, if we get 8 numbers, did we get 8 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 numbers. Well, realize we already started with 2, so really we got 10 Fibonacci numbers here. And as a result of going through this 8 times, because we're appending 8 additional numbers to this. And we can see, yes, it is, it's what you can see that's the first part of the sequence. And so, 13 plus 8 is 21. 21 plus 13 is 34. So yes, this is applying the logic for Fibonacci sequence. So that's great. And we're able to avoid duplication using a loop, which works really well. But and then we can extend this, right? We could say, hey, why don't we ask the user how many we want? So we could say numbers is equal to, oops, it's not a comment. Let's put the comment in first. Let's see. Ask user for numbers of numbers to get. And here we could say numbers is equal to, it's got to be an integer, so we'll convert it to an integer, and then we'll do an input. Please enter number of numbers you want. Kind of awkward, but it'll do. So now we could put that here, right? That would give us the number of numbers. And we could run this. And let's see, we wanted 5. Wait, we got more than 5. We got 5. We got 7. Oh, okay. So we already start with 2. So we need to say -2 to count for that, so that when we run this, we actually get the number that the user wants. So say 5, we now have 5 numbers. Okay, so this works nicely. But let's say we're going to use this multiple places. We would, everywhere in our program, we would have to type this whole thing out in multiple places. So while the loop gets rid of some duplication, if we needed to do this Fibonacci sequence in multiple places in our program, it would be nice if we could just write this code here all once and just make this into its own command, and then everywhere we needed it, we would just use it. So instead of doing all this, maybe eventually it would just be fib numbers is equal to some function, maybe it was called fib, and we would just pass in number of numbers, and then we would print fib numbers. It'd be nice if we could do that. But instead, and then if we had other places, we would do this. So it'd be nice if this could be abstracted, we say, if all of this could be abstracted into a function. So that's really what abstraction is, right now we have some good tools to avoid repetition, but now we'd like some tools to avoid duplication. And the way we can avoid that duplication of our code in multiple places in our program is by writing functions. So when you hear the term abstraction, what that really means is taking a block of code and turning it into a function so that if we need to use it in multiple places, we can just use that little function rather than having to write extensive amounts of code in multiple places.